Okay, so our next quiz on the next Tuesday is on these row column spaces that we have talked about, and also null spaces, by the way, so I'll add this here also, null spaces, and this is all material from 4.7. And what this is about? Well, we have a matrix and we have to calculate a basis, let me be more precise, a basis for the row space, a basis for the column space, and a basis for the null space. I might ask some of them or all of them, so depending a little bit on how big the matrix is and so on. Okay, so what we want is to find a basis. So find basis of these spaces here, the null space, the row space, and the column space. Okay. And the procedure is, as always, the same. We have to row reduce into, well, we'll discuss up to how far we have to go, depending on what we want to do. All right, so I'm going to do all three. So I'm going to go to the row space, the column space, and the null space. Okay. So we have to start with row reducing, at least in echelon form. So we have the 1 here, what we want, and so we're going to do row 2 minus 2 times row 1, and row 3 minus 3 times row 1. Okay, so what does this give me? 1, 2, 1, 0, negative 1, 3, 8. So we times this times negative 7, and we add up 0, 0, 0. That times that is 1, then minus, that's a 2, minus 6 plus 7 is 1, minus 16 plus 6 is minus 10. Okay, now we multiply with negative 3 and add up there, so I get 0, 0 again, 0, now we have negative 2, negative 3 times negative 1 is 3, minus 7, that is minus 4, minus 9 plus 7 is negative 2, minus 24 plus 2 is minus 22. Okay, so this takes care of this pivot. The next one is already, again, nicely done, so we don't have to worry too much here. So I'm gonna do row operation. I have to get the 0 there, right? So I'm gonna do row operation R3, replace that by 2 times row 1, row 2. Okay, so what do we have? These two first rows, nothing changes. And then here we get, so we multiply this times 2 and add up here, so 0, 0, 0, 0, another 0, another 0, and then minus 20, we're adding up, right? Minus 20, minus 22, I'm saying it right? Okay, it's minus 42. Sounds bad, but it actually isn't, right? Because what's the next row operation? We have now a 1 here, we have a pivot here, we only have to pivot there, but that's very easily done by the row operation row 3, replace that by minus 1 over 42 row 3. Okay, I'm gonna be, again, since I'm doing this with a video, I can do this, right? And the test, you shouldn't, you have to write things out a little bit. So I can replace this actually here now by a 1. Therefore, this row operation is no longer applicable. At this point, we already can answer 2 of the 3 questions. The row space. Let's start with the row space here. The row space, so basis of the row space, it's very simple because whatever we do, we never change it. And so we can use the rows that we have at the moment. So once you're in reduced echelon form, the non-zero rows are a basis. Be careful, the non-zero rows, okay? These are the bases. So we have as a basis here 1, 2, 1, 0, negative 1, 3, 8. That's the first one. 0, 0, 0, 1, 2, 1, negative 10. And then finally 0, 0, 0, 0, 0, 1, 2, 4, 6 zeros. Yeah, okay, 1. Okay, that's the base of the row space. But we have more. These pivot variables, I'll do them, I'll mark them again. These are the pivot variables. So the pivots, right? And they also help us in identifying a basis for the column space. So it is exactly these columns that will give us the basis, but we have to go back to the original matrix to get the actual values for the basis. So this is the first basis element, this is the second basis element, and this is the third basis element. So basis of column space we get, well, let me write them as columns, right, because that's what they are. So 1, 2, 3, 0, 1, negative 2, and 8, 6, 2. This has nothing to do with the review, but I want to point this out to you. I mean, you will probably by now have figured this out. How many basis vectors are there going to be in the row space? In this case, the number of pivots, 3. How many basis vectors are going to be in the column space? Same answer, because it also depends on the pivots. So the number of basis vectors in a space, it's called the dimension. The book doesn't, the syllabus doesn't want to talk about it, but I will say a little bit about them. So what it shows is that the dimension, the number of basis vectors, which is, it doesn't matter what basis you take, there's always the same number. So if you take the row space, it has dimension 3, and the column space therefore must have the same dimension 3. Okay, so now what about the null space? So the null space requires more. So okay, let me point out where we are, right? So at this point we have an echelon form. So once we reach that's the phase 1 part, right? Once we have the echelon form here, we can find the row space and the basis of the row and column space. But for the null space, we need to go, so now we need to go to the reduced echelon form, which it's so-called the phase 2 in our row reduction, right? Okay, so let's do that. Remember, this is now working the other way, right? So now we have to start from the back here, from the bottom one, and put zeros on top of it. Now it's rather sure what to do here. Again, it's a video, right? I can erase things here, so I'm going to erase this, give myself a little bit more space. Otherwise, I'm going to, for sure, make copy errors. Okay, all right, so here we are. So the row operations that I have in mind are using this one. So row 2 plus 10 times row 3, and row 1 minus 8 times row 3. Okay, so let's do the bottom one first, right? Because the first row. Okay, so we're gonna add. It's very simple, right? 1, 2, 1, 0, negative 1, 3. Nothing happens there because in the bottom we all have zeros, and then this becomes a 0. Okay, for this one, same thing. So the first step is always rather simple, right? Because there's nothing going on. Well, that's not true because there could be stuff here behind there. Sorry, in this case I meant. Okay, so in this case, that was rather quick. And then we need to put a 0 on top of this one. Yay, it's already there. Okay, so we're done. So what does this now tells us? Again, these are, let me use the same color, these were my pivot variables, right? So these are still the pivot variables. So now the pivot variables can be expressed in terms of the free variables. So these are now, so okay, let me call them now. This is x1, x2, x3, x4, x5, x6, and x7. These were and so we're gonna now write down these in terms of all the free variables that are the remaining ones. Oops, this is a 5 and this is a 6, okay. Okay, so let's see what this means. So I'm gonna have a big column here, x1, x2, x3, x4, x5, x6, and x7. But in this column, the green ones, so okay, these guys, they are just themselves. So this is just x2, and this is just x3, and this is just x5, and this is just x6. It's the pivot variables that we now have to write in terms of the free variables, and that is looking at these equations here. So we solve, remember this is equal to 0, right? And this, so in other words, we have to bring all these guys, this says 1 times x1 plus 2 times x2 plus 1 x3 and so on is equal to 0. So we have to bring these to the other side so they get negatives, right? So we get negative 2x1, negative x3, bringing this to the other side is a plus x5, this to the other side is a minus 3x6, okay? We have to do the same for x4. So x4 is equal to minus 2 times x5, right? This guy, then this to the other side is minus x6. There's no x7, so we're good. Oh yeah, cannot be no x7 because it's a free variable. No, that's not true. What am I saying? No, sorry. And so what about x7? Right, exactly, x7 is 0, right? x7, there's only one equation there, x7 is 0. That can happen, okay? And then what we need to do is write this actually as, break this down for each of the three variables. So that means, let me so we have an x2, we're going to have an x3, we're going to have an x5 and an x6. And so we make now the columns, that the coefficients of x2 in each of these rows. The coefficient here is in x, oh, that was a copy error, guys. Okay, that was an x2, right? I can only have 2, 3, 5, and 6 here in my, okay, sorry, that was a copy error. So minus 2x2, so we have a minus 2 there. The x2 coefficient 1 here, there is no there, so that's a 0. Here, there's nothing there, and this one, and this one, and this one, this one. None of these have x2 in it, so it's all 0. Plus, so now we do the same for x3. There's an x3 here, so that gives minus 1. There's none here, so we shouldn't circle it, right? There's none there, so that's a 0. There's 1 here, that's a 1. Then, and there's actually nothing else anymore, if you see. The four bottom ones don't have wait, now I did too many, right? 2, 4, 6. No, there should be 7. Okay, so I forgot. Well, okay, sorry. 7 is a bit much, right? I kind of. So we have to have 7. So I forgot a 0 here, I think. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yeah, okay, now I'm good. Plus x5. So what about x5? There is 1 here, so that gives you 1. Nothing there. Because these are 3 variables, so they're not going to play. A minus 2 here, a 1 there, a 0 and a 0. Okay, so this is the minus 2 and this is the 1. And then there's nothing x5s. Plus, and then finally x6, we have a negative 3 there. Nothing there, but then 1 in the next one. And that's the, no, there's also this one, has a minus 1. Nothing there, that's 0. We got a guy here, which is a 1 again, and then this is 0. And so these 4 columns that I have now, this is my basis. That's the basis. Okay? That's how you find the, so this is the basis of the null space. Sorry, let me make it more explicit. And going back to this thing I said, it's not part of the review, but I just want to point this out to you, is about dimension. So what is the number of basis vectors? We see there are 4 here. Now, what is that equal to? It's equal to the number of free variables, right? And where the dimension of the row space and column space was equal to the number of pivot variables. Okay, so 3 here and 4 there. And altogether there must be 7 because there were 7 variables. Okay. So let me do one more example. I have it already prepared here. Just, I know it's a little bit of work. It's going to be a bit long video, but it's good to practice these things. So we're going to use this one again. So row 2 minus 2 times row 1. Sorry, let me do this over again because I need the space. Let's do this. Row 2 minus 2 times row 1. Row 3 minus 3 times row 1. Row 4 minus 4 times row 1. And then row 5 is a row 5 plus row 1. I wanted to do an example with a bit more rows because that sometimes it's not clear what. Okay, so we get 1, 0, 3, 0, 2, 2, 0. So minus 2, we're doing this minus 2, right? So 0, 1, 1, 0, 2, 1. This is 0. This now, okay, now we have to do minus 3, 0, 2. Then we have 9, it's a 2. 0 then 1, we get minus 6, 6, minus 6, 2, okay, and then okay, so that's what we have now. Okay, and then the next one, we get now with negative 4, right? So we're going to multiply this negative 4. Okay, 0, negative 4, negative 12 plus 14, that is 2. We get a 1 here, minus 8 plus 14, that is 6. minus 4 plus 11 is 7. Okay, and then finally we have to add up 0, 0, 0, 3, 6, 0. Okay, good. About the 0, so we need now, this pivot is taken care of. Next pivot, yep, we do only one thing that we need to do, row 3 minus 2 times row 2. Okay, so we get 1, 0, 3, 0, 2, 2, 0, 1, 1, 0, 2, 1, 0, so we multiply with negative 2. 0, 0, like that, a 1, 4, that's a 2 and a 0, okay, and then we have 0, 0. What are we doing here? 2, 1, 6, 7, 0, 0, 0, 3, 6, 0. I hope I didn't make any mistakes here. I have the feeling that I made somewhere a mistake. Let me see, because did I do this right here in row 4? I have to multiply with negative 4, so that was a 0, that's a 0. Then I had to do, negative 4 and add it to here. That was 0, 2, 2. No, that's 2, right? No, sorry. I have to look at this. I want to see here. Give me a sec here. Because something doesn't seem right. No, this I made a mistake. Let me see here again. Where did I make a mistake? Perhaps in this one, in the third row, I have to multiply this with negative 3, 0, 2, that's it, times negative 3, right? Yeah, that's correct too. I see what I made the mistake. It's in the fourth row, but here I have to multiply with negative 4, and so we get a 0 here. This is a 2 here, okay. Sorry, I knew that there was something more to cancel, so that's why I'm saying this. So in other words, we have to do the same row operation here, also row 4. That will be row 4 minus 2 times row 2, okay. So, right, so let me erase this row here. That's this row that is not correct, right? Okay. So I have now, I have to multiply with negative 2 and add up here. So that would be a 0, 0, 0, 1. Okay, where am I here? This times negative 2 plus 6, that's a 2. And then negative 2 plus 7, that's a 5. Now we're cooking. Okay, so we have another pivot here that we're going to have to work with. That is row 4. So these the two bottom rows, right? Row 4 is row 4 minus row 3, and row 5 is row 5 minus 3 times row 3. Here you see, small little mistakes can make things really hard, because then all of a sudden I have fractions there, okay? So in the previous case, I would have had this 2 that I need to make a pivot, and then the only thing I could do was make it into a fraction. So I'll normally try to avoid fractions. It's not always possible, but if you run into fractions, you could always think, oh, perhaps this was not something that was supposed to happen, especially not in this question. When the determinants and inverses, it's inevitable almost to not have fractions. Okay, go on, keeping on. So we're going to multiply, we're going to subtract this from that. So get 1, 0, 3, 0, 2, 2, 0, 1, 1, 0, 2, 1, 0, 0, 0, 1, 2, 0, 0, 0, 0, 0, subtracting 0, subtracting 5, okay? And then same thing there, 0, 0, 0, now times negative, so it times negative 3 and add up there, 0, 0, 0, okay. And we're almost done, we need a pivot here, so that is done by the row operation, row 4 divided by 5. And I'm gonna again cheat a little bit and do it right here. Okay, so we have now this, oops. Okay. I didn't remember where it was, okay. And a 1 here, let's do it back. So, what are the pivots, right? We are in reduced echelon form, we are in echelon form, so let me write that again. So this is echelon form, so we are ready to do row and column space. So we look at the pivots. Remember, the pivots are the first non-zero elements in a row, and they have to be ones. Ideally, it's not really necessary for this kind of argument, but later on we need ones if we want to go to the reduced echelon form. Okay, so these are the ones, these are the pivots. So this tells me that the column space, so for the column space, so basis of column space would be careful, not the 4 columns, but the corresponding 4 columns, so the first, second, fourth and sixth. So this, second, fourth and sixth. Okay, so this is the basis for the column space. I'm sorry, I'm not gonna try to copy it because it's on a different page. So I'm just indicating those 4 as the basis, okay? Now, what a row space, and so for the row space, basis of the row space, let me do it in a different color. So, basis of the row space. Now, be careful. Now, don't go back to the original one. It might be correct, but it might be wrong. You don't know this. But the only thing you for sure know is that if you take these guys, so these are a basis of the row space. There's 4 non-zero rows, okay? And again, the dimension is 4 in either case, right? Okay. So now we need to go to the null space. Let me get rid of this here, okay? So null space, and for that, as I just told you, we have to go to the reduced echelon form. Okay, so what are we dealing with here? This one, I have to put zeros on top there. So what the operation I'm going to do is, so this is gone, is row 1, replace that row 1 minus 2 times row 4. This is the 4th row that this one is in. And then row 2 is row 2 minus row 4. Okay. 1, 0, 3, 0, 2, 2. No, sorry. 0, right? Yes. So we multiply this with negative 2 and add up there. And we have multiply this with negative 1 and up there. Since there are everything zeros everywhere else, so it actually is rather simple in this case. So that's what I get. And then I have 0, 0, 0, 1, 2, 0, 0, 0, 0, 0, 0, 1. And again, it's actually so nice that you're already done here because those pivots are have already zeros on top of them. Okay, and of course, in general, it could be that you have to do more, and probably I'll give you a matrix where you have to do a little bit more than that. Okay, I'm not copying the 0 row anymore because it plays no role anymore. So now, what this means is, remember, we have the pivot variables, so we have now 6 of them. So let's put down. So you have x1, that's a pivot variable, right? x2 is a pivot variable. Then the free variable, I'll use different colors, is x3. This is a free variable, and also x5. So this will be x5 will be here, and then we have x4 and x6. These are my pivot variables, and so I'm going to have to write them in terms of, so x1 first. x1 is, we have to bring these two guys to the other side, that is minus 3 times, so perhaps sometimes it's better to write here at least these guys on top of it, okay, otherwise you get lost of what's going on, okay, so we have minus 3 times x3 minus 2 times x5, remember we bring this to the other side. x2, well that is We have the minus x3 here, and then also minus 2 times x5. x3 is just x3. x4, okay, there's an x4 here. We bring this to the other side. Well, sorry, we bring this to the other side, so we get a minus 2. So minus 2 times x4. Sorry, I'm getting a little bit out of line here. So x5 is x5. Okay. And then x6, again, because of this thing, x6 is 0. I guess I give 2 examples. That's not always the case, right? But okay. Good, that's it. And so what now? Well, now we have to solve for, we look at the elements that have an x3 in it and the elements that contain an x5. And that gives me the basis for the null space. So we get a minus 3 from here, we get a minus 1 there, we get a 1 there, and then zeros everywhere because there's no x3 anymore. For x5 we do the same thing, we get a negative 2 there, another negative 2, a 0 there, a 0 there, and there's a 1 here, and then 0. And so this is now a basis of the null space. Okay, and again, if just about this dimension thing, there were 6 variables, 4 were pivot variables, that means that was the dimension of the null space and also the column space, and there are 2 free variables, that was the dimension of the null space. Okay, that's the review for the test.